Okay, this is going to be a video about interpreting and behavior on a variety of functions with different representations. Just as a reminder, yesterday we looked at how you can determine the end behavior of a function by comparing it to a similar model if you know the leading coefficient and the degree of the polynomial. So pause the video and try these 4 problems. Okay, at this point you should have completed these on your own. So for number 1, I noticed that it has a negative leading coefficient and it has an even degree. And because of that, it's going to look like this. It's going to follow the model of a parabola that goes down. So both the right and the left go to negative infinity. Now number 2 has a positive leading coefficient and an odd degree. So I think about a line that's going up. And on the right side, it goes to positive infinity. And on the left side, it goes to negative infinity. For number 3, I've got a negative leading coefficient and an odd degree. So this is going to be like a line going down. On the right, as x goes to infinity, the function goes to negative infinity. And on the left, as x goes to negative infinity, the function goes up to positive infinity. And then number 7 has a positive leading coefficient with an even degree. So the model we're going to compare that to is a parabola that opens up. And on both the left and the right, they are going up towards infinity. Oops, that's kind of bad looking, whatever. Last night's homework, answers are up on Drive. You are welcome to pause the video if you just want to compare them to these. Here you go. Okay, so what I'd like you to do now is please open up your packet to where it says all about behavior on page 5 and pause the video. And what I'd like you to do is go ahead and fill in the table. So fill in the function type, the degree, if that degree is even or odd. I also would like you to add a column here for leading coefficient. And once you do that for each row, go ahead and fill in the end behavior. Okay, at this point you should have tried all the problems on page 5, and you'll see that number 1 is the function type is linear, and we see that the degree is 1 because it's linear, which is an odd degree. The leading coefficient is 2, and because of that, again, I've got a line that's going up. So on now, you'll notice that the way they wrote it in, they put the left first and then the right, the left first and then the right. So just be careful there. Here's the right, here's the left. On the right, it's going up. On the left, it's going down. Okay, so now number 2, the function type is also going to be a polynomial. It's a quartic function. Its degree is 4, which is an even degree. The leading coefficient is 1, and because of that, we're going to follow the model of a parabola, and they both go up to infinity. Now, number 3 is not a polynomial function, so I'm not going to worry about this part. Here I've got an exponential growth function. Because it's an exponential growth function, it's going to look like this. It's going to look like that, and here we've got the right and the left. On the right, it's going up towards infinity. But on the left, we see it's headed towards that asymptote here at 0. So that's a little different. Number 4 is another polynomial. It's a cubic. Its degree is 3, which is odd. The leading coefficient is 1. Because of that, we're going to follow the line rule. So on the right, it goes up. On the left, it goes down. Number 5 is also a cubic because it's a 3rd degree. The leading coefficient is -2, and because of that, I'm going to follow the model of a line going down. Here's the right, here's the left. The right, as x goes to infinity, the function goes down. As x goes to negative infinity, the function goes up. Now number 6 is a completely different type of function. It's a logarithm function. So I don't need to worry about this. And I want to remember that a logarithm function, different color here, There we go, nice and bright. A logarithm function is going to go up on the right. But on the left, now this is a totally new phenomenon. When I look on the left here, and I try to follow as x goes to negative infinity, there is nothing here. Now I know that there's a vertical asymptote here, and as you learn more about end behavior and something called limits, you will learn how to describe this behavior. But as far as end behavior goes, we're going to say NA for not applicable, because the graph just doesn't exist as x goes to negative infinity. Number 7 is written kind of funky, but really, it's just quadratic. If I were to multiply these together, I would get a quadratic function. Oop. The degree is 2. It's an even degree. The leading coefficient is -2, and it's quadratic. It's a parabola. It goes down. Both sides go down. Number 8 is a square root function, so we don't have to worry about this stuff. Now it's the square root of x minus 3, so it would go down like 1, 2, 3, and it would look something like that. Now, again, like the logarithm function, it's going to go up towards infinity. Not that fast, but it's going to get there. But on the left, there's nothing here. Like, there is nothing here. So I'm going to say the left end behavior is not applicable. For number 9, if I were to multiply these together, I would get a cubic function. Its degree is 3. It is an odd, and the leading coefficient is 3. Because it's odd and it has an even coefficient, leading coefficient, it's going to be an up. As x goes to infinity, the function goes to infinity, and as x goes to negative infinity, the function goes to negative infinity. At this point, I'd like you to pause the video and examine the graphs on pages 6 and 7 and work on their end behaviors. All right. So at this point, you should have worked on pages 6 and 7, and we're going to go ahead and go through it. Number 10, the function type is linear. It's a line. The degree is 1. That's an odd degree. Now, it's also probably worth noting that this is a line going up. It's got a positive leading coefficient. It didn't ask us for that, but it's probably worth noting. And as a result, I can see here on the right and the left, as x goes up, the function goes up. As x values decrease, the function values themselves decrease. All right, so for number 11, the function type looks like it's some kind of polynomial function. Because I have a little more experience than this, I know it's a cubic function. But honestly, you really don't need that to answer the end behavior. Just nice to notice. I can tell it's an odd degree because of the fact that the arrows go in opposite directions. So that definitely you could fill out. These two are, they're maybe. So on the right, the function goes up. On the left, the function goes down. Number 12, we have another exponential function, but now we have an exponential, still growth. So this is not applicable. On the right, I see the function goes up, and on the left, I see it's approaching its asymptote at 0. Number 13 is a quadratic. I can tell that because it's a parabola. Degree is 2. It's got an even degree. And not that you really need this for the end behavior because you're given the graph, but it does have a negative leading coefficient because they both go down to negative infinity. Number 14, the function type is cubic. Third degree odd. And again, I can tell it's odd because, again, they're going in opposite directions. On the right, it's going up, and on the left, it's going down. 15 is another exponential. The difference is now I've got exponential decay. So this is not applicable. On the right, now it's approaching 0. And on the left, it goes up. Right, so now what we're going to do is we're going to examine some of these functions we've been looking at on page 8, and we're going to do some comparisons. So I'm going to spread out all my work so I can take a look at all my function types. Okay, so it says compare numbers 4 and 5. So here are 4 and 5. Just as a reminder, there they are. Which has a greater value as x goes to infinity? Well, when I look at these, I immediately know it's number 4, because number 4 as x goes to infinity is going up and number 5 is going down. So I'm going to say number 4 has a greater value because it is increasing, but 5 is decreasing. Complete sentences, please. Compare numbers 6 and 12. Well, number 6 is that logarithm function, and number 12 was an exponential growth function. Which has a greater value as x goes to infinity? So even though they have the same end behavior, I mean, they're both going up, we want to say that number 12 will have a greater value because exponential functions grow faster than log functions. Ooh, that's terrible. Grow. Compare numbers 8 and 10. So I see that number 8 was that square root function. And number 10 was a line. So battling it out today is the square root and the line. Which has the greater value? The line is going to go up at a constant rate, whereas the square root is going to start to taper off. So the line grows at a constant rate and will have the larger value. Compare numbers 2 and 4. So 2 is an x to the 4th power, and 4 is an x cubed. Which of these polynomials has the higher degree? Duh. All right, compare 7 and 13. Okay, so they're both quadratics. They both go down. So that's awkward. So I noticed that number 13 has a vertex at -1, 4. So my wonder is, will number 7 have a vertex higher than -1, 4? So I'm going to pull these up for a second. Here's number 7, and I can see it's got roots at 7 or at 3 and -4. So, and it's got that dilation. So if I kind of transpose that information onto number 13, which is what we're comparing number 7 to, so let's see. I'll do it in like a color. I'll do it in pink. So here, 3 and -4. Okay, so these are my x-intercepts for number 7. And I also know that I have that vertical dilation, so it's not going to be like a real low graph. It's going to be pretty high, and see, it's probably going to look more like that. So I would guess that number 7 is going to have a higher maximum. Okay. Compare 8 and 9. Which has a greater average rate of change from 15 to 20? So let's see, 8 and 9. Well, 8 is a square root, and 9 is a cubic. And if I'm comparing average rates of change, I would pick the cubic because cubics grow faster. Than square roots. Compare 12 and 14. Which grows faster as x goes to infinity? Alrighty, number 12, or number 12. Oh, number 12 is that 12 is exponential growth. And 14 is a cubic. In the fight between the exponential growth and the cubic as x goes to infinity, exponential growth always grows faster than a cubic. I mean, exponential growth is pretty much going to be almost every function we've learned so far. I mean, think about when you put an exponential function into your calculator and you look at the table, how fast those y values get really, really big. All right, ladies and gentlemen, at this point, you are working on your homework, which is page 9. I'll put the answers up so you can pause the video and check them as needed. Here's the homework.